Right, by now, obviously, you should know what a function is. Okay, as I told you last time when I first introduced the trigonometric functions and their graphs, I told that a function is a mathematical relationship between any two variables. Usually, okay, you have one y value corresponding to one x value. So you always have one input value giving you one output. The output will always be one value. But sometimes you can have two inputs giving you one output. That's a unique case which we are going to talk about later on. So a function is a mathematical relationship between two variables. Okay, the variables are usually x and y. Okay, x we call it the independent variable or the input variable. X is called the independent, I'll put forward slash for all, or call it the input variable. Right? Y is called the dependent variable. Okay, you can also call it the output. Okay. Right? So I spoke about this last time. But I just want you to be aware that in the past we used to teach this topic first before the trig graphs. Okay, it was only this year that we started with the trig graphs. Then we are doing the algebraic functions. Now these are called algebraic functions that I'm going to talk about now. That is the linear is going to be the first one that we did last year, and I'll introduce three more that you didn't do last year. So these are some of the basic things that you need to know. Generally, for you to have a function, there must be one x value corresponding to only one y value. Okay? But in grade 10, we don't get into the details of the definition of a function itself. Right, so that's the first thing. Then the next thing, you need to know the definition of domain, definition of range. Okay, we have discussed that under the trigonometric function, so that shouldn't be a problem at all. So we have got domain. You should know that is the set of all the x values. The set of all the x values. Okay, and your range is the set of all the y values. Okay, then function notation. Now, function notation is going to be very, very important under this topic, right? So, function notation. I'm repeating what I have spoken about already, because it's very important for you to know. Okay? Y is replaced by a new notation function notation. Okay, right? So we say f of x is equal to y. We say f of x is equal to y, where, let me put a comma, where f of x is pronounced as, let me use a different color there. It is pronounced as f of x. Okay. Right. You can also have g of x, t of x, h of x, and so on. And I've spoken about that under trigonometric functions. Let's do some examples on function notation. Let me create my own question. Since you haven't done the other functions, I will just talk about the linear function. So let's do examples on linear function notation. Can I carry on? Right. I just want to emphasize this part. I don't expect anybody to get confused at this stage when you see f of x, when you see g of x, when you see h of x, and so on. All of them, they are equivalent to y. Okay? So y is replaced by f of x, g of x, h of x, and so on. So the moment you see h of x, f of x, what must come into your mind is that this is y. Okay? If you don't get that part, then you might have made a problem. Right? Yes? No. But you see, in maths, you have to know your definitions because they help you to know to be familiar with the terminology and also to be familiar with the foundation of what you're supposed to do. So in terms of these definitions, they are very important. If you get a question on range, you need to know what is range. If you get a question on domain, you have to know what is domain. You also need to know what is a function itself. Okay. Well, surely, if you are curious, when you see a person saying a function, you need to ask yourself, what is this? It is just a mathematical relationship. Okay. Right. So examples on function notation. But let's just say you are given f of x equal to, let's deal with the linear function because you guys are in grade 10. So far you've only done the trigonometric function. Okay, now we are doing the algebraic. The linear function is an algebraic function. Right? Right. Determine, let's start with A, right? Let's say F2. Okay? So if you are given f of x equal to 3x minus 2, and then the question says determine f2, it means you want to find the value of y. This f2 here, it means y. You want to find the value of y when x is 2. Okay? But based on function notation. So what this means is this x here, which you see in the original equation, and that x, they are being replaced by that 2. Okay? So when you do the question, I'm going to write the solution in green. So we write our equation is f of x equals to 3x minus 2. So what this means is I'm going to find f2. So I'm trying to find y when x is 2. So this becomes 3 times 2 minus 2. And then you get f2 equal to 6 minus 2. And your final answer will be a 4. So what this means is, when x is 2, y is a 4. In grade 9, where I put f2 there, you are putting y there. Okay? But because of this new notation, which is called function notation, where we are putting y, when we have a specific value of x, we put that specific value of x inside the bracket, then we put the letter f. Okay? We'll start by writing the letter f, then we put the specific value of x in the bracket. But f2 is a y value. It just means the value of y when x is 2. That's what it means. Okay, so that's the first example. Then let's do B now. Remember, we are still trying to determine now. Right, you can also get a question whereby you can be asked to determine, say, f of x plus 2, like that. So by f of x plus 2, we are saying add 2 to y. It's not complicated. Where there is f of x here, you just replace this f of x by 3x minus 2. Now, f of x plus 2 is going to be a new function. And based on graphs, it means we are moving this linear function by 2 units up. Okay, that's what it means, right? So, okay, just to summarize this is equivalent to that. They are the same. Okay, because on the right hand side, on the left hand side, we have got f of x. So where I have got f of x here, I can replace that by the right hand side of the original equation. It's not complicated. That's why I get surprised at why learners get confused with the notation. Because it's more like saying, I'm going to come and sit where you are sitting. If I come to you and force you to stand up, and then I'll sit where you are sitting. So in that case, if f of x equal to 3x minus 2, it means in that expression f of x plus 2, all I have to do is substitute the right hand side where there is f of x. So the right hand side replaces f of x. In terms of graphs, it means this linear function, okay, it's a linear function, the one that you did last year, which is of the form y equal to mx plus c, right? That linear function, you are moving it by 2 units up. That's what this means. But in this stage, we are not talking about sketching the graph. So let me find what this is equal to. So f of x plus 2 is going to be equal to, where there is f of x here, I'm going to put 3x minus 2, so it will be 3x minus 2 plus 2. And the final answer is going to be 3x. Okay? Now, I can visualize this as this graph. I hope you know that the minus 2 is called the y-intercept. From grade 9, it's called the y-intercept. So it is the value of y when x is 0. If you move this graph by 2 units up, you get to a point where, okay, let me show you a little bit. Okay. I'm allowed to do this because this class I can do that, right? Provide you with more information. Okay, let me try to sketch it here. Let me sketch it here. Like this graph here, it has got a y-intercept at y dot minus 2. Okay? The x-intercept is negative. Sorry, the y-intercept is negative 2. Right? We may need to find the x-intercept by substituting y equal to 0. If I put y equal to 0, it means x is going to be equal to 2 over 3. Right? So, if I sketch it, please, this is just a sketch. If I put 1 here, it has got a positive gradient. the y-intercept is somewhere there. Like by the dual intercept method. Okay, did you do that in last time? Have you ever heard of the dual intercept method? How many of you, okay, how many of you did the linear function last year? When did you learn about y equal to mx plus c? How many of you learned about y equal to mx plus c? Raise your hand. Raise your hand. So it means it's the bulk of it, right? But you are a bit rusty, so let's remove the rust. Or you remove the rust as quickly as possible. Right? When you are sketching a linear function, the best method is called the dual intercept method, whereby you determine the x-intercept, the y-intercept, you plot those points, then you take a ruler, you join the point. Because a straight line will always pass through the x-intercept and the y-intercept. Okay? Always. Alright? So the y-intercept, you don't need to calculate it. It's there in the equation, like in this case. This -2, okay, let me highlight it. This -2, that's the y-intercept. You have to know that it's part of this topic. It's part of this topic. If you forgot, then you refresh it. Right? So that's the y-intercept. Right? You can also get it by substituting x equal to 0. But if the equation is on form y equal to mx plus c, you don't need to do a calculation. You can just get the answer by observation. So the y-intercept is -2. The x-intercept, you get it by substituting y equal to 0 here. So if you substitute y equal to 0, take the -2 to the left, divide both sides by 3, you will get 2 over 3. So I hope you are following me. Right? So if I can approximate 2 over 3 can be somewhere there. This is -2. So if I sketch it, it will look like something like that. Please just assume that it's a straight line. The gradient is positive. That's the coefficient of x. Right? That straight line, if you move it by 2 units up, that's what this means. Okay? You move it by 2 units up. This point moves to the origin. Okay? And this point, this x-intercept, the point here, moves by 2 units up. Okay? So every point along the vertical line moves by 2 units up. That's why the new equation is going to become y equal to 3x. Because there is no y-intercept because the graph is now passing through the origin. So both the x and the y-intercept are equal to 0. Yes?
The vertical shift.
Yeah, it's vertical shift.
So that is the vertical shift.
Yes, it's the vertical shift. This +2 is the vertical shift. Okay? Don't worry, I'm going to come back in more detail to the linear function. Right? But I just need you to be aware of this. So f of x plus 2 is going to be equal to 3x. Okay? Then you may also get a question. Let's say, okay, let me move on to the next page. And you can get a question like this. So we are now doing C, where you may ask to determine, say, let's say, okay, I've used 2 before, so let me use another value. Say -4 f of x. Okay? -4 f of x. -4 f of x means multiply y by -4. That's 4. Okay? So -4 f of x. Rather, let me write the original expression. We know that f of x is equal to 3x minus 2. So -4 f of x will be equal to minus 4 times what's on the right hand side. Okay? So this will be 3x minus 2. And this will give me minus 12x plus 8. Okay? So by minus 4f of x, we are saying multiply y by negative 4. So we multiply the right hand side by negative 4. Okay? It's not complicated. Right? You can also have cases where you can have division using function notation. Then, but here's what a question there. Then, but here's what a question. That I'll give you homework on function notation. All right, let me introduce the linear function. Okay. So, in grade 10, we are going to learn about 4 functions. Okay. So, okay, let me call them 4 algebraic functions. Because if I say functions, it will include the trigonometric one. So I'll say algebraic functions. We did the trigonometric function, but now we are doing the algebraic. So, right, the 4 functions are, right, let's list them. Then I'm going to talk about them one by one. We'll start with the linear, which is grade 9 revision. Right? Linear function. Okay, this is also called the straight line. Okay, so sometimes if you hear me saying the straight line, I'm referring to the linear function. So don't let it get confused. Right? Then you will learn about what's called the quadratic function. Right? The quadratic is also called the parabola. Okay? Then we have the hyperbolic function. Okay, which sometimes we just call it the hyperbola. However, you can pronounce that way. Then the last one is the exponential function. Okay, so we're going to talk about all of them one by one, their properties and so on. Right, so far we only have done the linear one, right? So let me just talk about some of the things quickly. Okay, we have done it in grade 9. Now the linear function is very important because it is more like the simplest of all the functions. Okay, later on. All right. So let's start with number 1, the linear function. Okay. So in terms of the properties, okay, first we will talk about general equation. Okay, the general equation is y equal to mx plus c. Okay. Okay, then B, let's define some of the things. So this is the general equation, the straight line, y equal to mx plus c, right? Okay, maybe if I say word, let me change that and say, okay, so I'll say where m is the gradient, okay? M is the gradient, right? And its formula is m equal to, we can use y2 minus y1 over x2 minus x1, right? Also, I'm aware that last year maybe your teacher taught you that the gradient can only be calculated by using the formula y2 minus y1 over x2 minus x1, am I right? Now, some teachers, they don't tell learners that you can also say it's equal to y1 minus y2 over x1 minus x2. So this is also equal to y1 minus y2 over x1 minus x2. What's very important is that the subscripts for x and y must correspond. So if you start with y2 in the numerator, then you must start with x2 in the denominator. If you start with y1 in the numerator, you must start with x1 in the denominator. You get the same answer. It's just that in grade 9, teachers concentrate on y2 minus y1 over x2 minus x1 to avoid complicating things, but you can do it either way. And this one or that one. So during my teaching, depending on how I feel at that moment, I can start with y1 or I can start with what? With y2. You shouldn't ask me why is it starting with y1 now, why is it starting with y2? It's the same thing. It's just that because you'll be dealing with a straight line, you can choose any of the 2 points, which one is your y1 and your x1, y2, x2. It is a choice. Okay? So you need to know this. Right? C, okay, let me write it here. C is the y-intercept. Okay, don't be expressed. C is the y-intercept. Okay? C is the value of y when x is 0. So you get the value of C when x is 0. You substitute x equal to 0, then you get C. Okay? Right. So the general equation. Then B, I just want to talk about parallel lines. Lines that are parallel. Okay, the lesson ends at 9, isn't it? So let me talk about parallel lines. Right? If two straight lines are parallel, means that their gradients are equal. If two straight lines are parallel, if two straight lines are parallel, you can do it with a formula. It means that their gradients will be equal. what we are talking about is this. If I draw, okay, I can draw nicely, but I don't have time. Let me just do it this way. Obviously, this is x, that's y. So if I draw, okay, I think it's better for me to just use the straight line here. Let's use that one. Okay, then if I call this one here, if I call this one L1, that one L2, okay, what that means is the gradient of M1 will be equal to the gradient of M2. This is only true if the lines are parallel. Okay, this is only true if L1 is parallel to L2. Okay, so if you've got two lines that are parallel, it means that their gradients are equal. Please take note, by M1, I'm saying gradient of line 1. By M2 means gradient of line 2. Right?